All right, so I'm live with simulating Python from zero. And what I'm going to do is cover list comprehensions today. And that should be a lot of fun. Let's go ahead and dive right into it. And I'm going to go into my code space and get this working. All right, so I'm inside of this environment. And the next thing that I'm going to work on as an example is the concept of list comprehensions. And I think what we can do is make a directory called example lib, this, and we'll touch example lib and make an empty file here. That, and then inside, I can put in different tutorials. So I can say list this comp tutorial, something like that. There you go. Example touch example lib. There you go. And now I can just actually open this up, example lib, like this, and we can start off with making some kind of example. Now I am going to tweak things a little bit too, just make sure. I want to install the nightly copilot. Pilot would be this one, nightly, and this one, perfect. And we'll uninstall that. We got that working. So I think I've got everything I need now inside of this environment. Let's look at the, yeah, it looks pretty good. And Python, that works. Perfect. I think I want to rebuild this environment real quick. So let's just rebuild. There we go. This will just reload all the extensions because I'm going to use the latest version of Copilot, the nightly build, because I like to use the bleeding edge stuff when I'm developing. Okay. Let's look at this logs here. So I guess supposedly what I could do to speed this up in the future is that I could tell this thing to pre-build the environment. So in case I need to pre-build these things, I can do that. Assimilate. Python from zero. Here we go. If I go to settings and I go to code spaces, we'll just set this up as a pre-build. There we go. And it should just launch quicker in the future. Okay. And that is one of the cool things about the code space. This is a little bit of a one-off because it needed to rebuild to reinstall the nightly version of Copilot. But now that I've got this working, hopefully we should be good to go here. Great. All right. So next up, I'm going to go right into example, go to list comprehension. So first, let's just build a regular list. So I would go through here and just say build a list of animals. And let's see what happens. Is our Copilot, let's double check it's installed, and it's not, which that was kind of the whole point. Copilot. We want to do nightly version, this one, and we want to do experimental labs, exactly. And we want to add dev container settings. And we can just add this to, I would say, a probably just a generic Python environment. This one. And then we want to add the feature lab. That's already done. This is already done. Yeah, add this one as well. So now that we've got these added, if we go to this, we should see, there we go. This is what we wanted. Okay, got that. So next time, I mean, I guess I could just check it in real quick, is I just say git status, add .dev container, add example lib, adding config. So this means that in the future I could rebuild things quicker. Great. So now if I say here, I say build a list of animals. What do we got? There we go. That looks good. So now that I've got that, typically what you do when you want to actually run through an example or loops through something, you'd use a regular loop, right? So we could just say, build a regular for loop in the animal. And if we run this, say Python list comprehension tutorial, which would be example lib, right? And we see cat, dog, monkey. But you can also build a tighter loop by building a list comprehension version. And so basically it's just a backwards version of what it is you're building. And so the example here is exactly right. It's a one-liner. And the reason that you would use a list comprehension is that it can do loops at a C-level speed. And that's really why they can be advantageous. So I guess what we could do is we could actually try this out. We could basically benchmark a couple different ways of looping, which would be kind of fun to play around with. But let's again run it real quick. There we go. We have the regular, and so I think this would be a fun thing to do, is to try out the list comprehension style to see if we could build out a benchmark. So let's first build a slow one, and I guess what we could do is just comment all this code out, since we don't care about it. We could just build it right in here. So I guess we would build out version 1, which would be build a list of random or actually build a list of numbers. Let me think about this. We would want to loop. Yeah, build a list of random numbers from 0 to 1,000,000. Right? And if we do that, so we have this like random numbers here, and so Now, if we wanted to do the same thing, a regular for loop for number and numbers, print numbers, you can see that you would loop through and get a certain amount of time that it would take to run this. And so, I guess one of the ways that we could do this is I would say, build out two versions. So we could say, profile the time it takes to run the for loop, and so you could do something like this, but we want to do with. The easiest way is not even to write in Python, is to actually just time it, and so we can just do this. We can say. In fact, we probably don't even want to print the number. We could just say for number and number, just say pass, right? Because it doesn't do anything, but it'll just run it. And so if we run this, in fact, well, that was actually pretty fast, shockingly fast. If I time it, it should see that it took for number and number. We could also just make it like keep track of something. So we could say like collects and do that. We would say collect.append number, something like that. And let's just see how long that takes. So actually, surprisingly, if we add maybe a couple more numbers, zeros to it, let's try that. We want something that's kind of meaty to run. So it might be too many numbers. But it took 14 seconds. That's a good example. So this is a super expensive loop here. So we'll say, put in here like, unoptimized took 14 seconds. And now what we need to do is comment this out here, like this. Let's build a V2. So we'll build a list comprehension version, which would be also collects equals this. Oh, actually, yeah, we probably would want to do something like for like this. We would want to say collects, and we'd say collect.append. Yeah, and let's see what happens. How much faster is it? And let's run it. So it may be the case that I'm wrong. It doesn't. It is faster. So this was 13 seconds. Now what we don't know is appending to a list, if that's a bad thing to test, because that could be the bottleneck. But we do know that was a little bit faster. And probably let's take away 10 because it's a little bit too much. And let's do that. So that took 1.4 seconds. And really what we probably want to do is have two scripts. So let's do that. Let's build another one. So we'll call this touch example lib, and we'll call this comprehension the like regular list, regular, and then we have the one with the other ones. So if I go to the regular, we just need to grab this, and then we need to grab a collects. Now, this obviously is also a list comprehension, so we don't know what it would be like in this particular scenario to do things in this way. Now, I am curious actually what the type is of this. Let's go ahead and say type numbers. So if I run Python example, what is that? Tip. I'm gonna type. What is this thing? It is prints type. The list. Well, so really, then I'm not doing this right then. So in this particular scenario, I wish I could avoid running that piece of code because it's kind of fooling the problem a little bit. But basically, in this scenario, this list comprehension scenario, what I could do is I could just say for number in numbers, right? Because basically it will return back a list. We could even say collects like this, because this will return it. And let's just run the first one. Number. Let's see, build a list comprehension version. Collects is equal to number for number in numbers. Okay, so let's build that one. Wow, super fast. Now, if I add a 0 to it, let's see what happens. The problem was I was bottlenecked on the append. So that took 8 seconds. So if I do the same thing to the other one, we can see it's twice as fast essentially, because basically if we grab this one, and I also don't, unfortunately, this we don't know how long that takes, but I think it's pretty quick. But basically, if I grab this thing and then I grab this part, we can make something similar. So if we wanted to have the unoptimized version, you can see here that it's much. This is regular. But this, we would want to do time, and we want to make sure that it's the same amount of time here with both. There we go. So we'll say time, and we can see that this probably will take 13, 14 seconds to run. So it's twice as fast, basically, by doing a list comprehension. So that's convincing me that these are, so 15. So I'll just put this as a note here that it took 15 seconds. There we go. So it took 15 seconds. Run my machine. There we go. We got that. Perfect. And this one, if we look at the regular one, this one takes half as much time, right? So that's a pretty big win, actually, when you think about it. Half the time, I think most people would really want this when they're building things out. So that's, I guess, in a nutshell, why people care about comprehensions. Is they're really an effective way to build up speed in a program. And you can see it's it's really just this. It's just a loop that's been put into a different form that makes it pretty quick. So I think that's a good enough tutorial for list comprehension. I will do get status here, and I will add all this in, commit it, and that's it. Adding list comprehension.